Alright, I'm just waiting for everybody to be up to join the chat. Let's give them a few minutes to see the notification and come on. Welcome guys, I see you guys coming on. Let me just shoot out the link. Come on, join up. Alright, so good afternoon everybody. Good afternoon. I see you guys joining. I just waiting on the persons to come on. Alright, so the rest will eventually come. Good afternoon guys. My name is Ramin. I am the PRO for ChemSoc. Welcome to another meeting. Nice to have you here. Can you guys just send a hi or a wave or something in the comments so I know that you're there? Hi everybody. Alright, so Trishane, well, good afternoon. Good afternoon, Akilia Ewers. I hope I pronounced that correctly. Welcome guys. So yeah, so today we'll be doing the flame test experiment. Alright, good. I see you guys coming on. Hi guys. Good afternoon. Yeah. Oh yes, I just seen your comments coming in now. Hi guys. So yeah, so today we'll be doing the flame test. Alright. So before I begin, I make sure I big up the persons that are here. So Paul Witter, afternoon boss, big up. Miss Gibbs, nice to see you. Tiffany McG, welcome man, welcome. Sir Matthew, alright, respect sir. Yes, we got this. We got this. We have Jamelia Morgan. Hi Jamila, welcome. We have Michaela Miles. She's saying hi to everyone, so make sure to respond. Hi Michaela. Alright, this is what? Jay Wilson. Okay, hello. We have Sharika Campbell. Hi Sharika, welcome. Welcome to the meeting today. So yes, as I said, we'll be doing the flame test today. So today we'll be doing elemental flames. So can anybody just send me a comment? What do you think this experiment is about? When somebody says elemental flames or the flame test experiment, does anybody have any idea what the experiment is about? Anybody just shoot a comment so I can see what you guys have in mind. So anything, what do you guys think we're going to do today? This thing has a delay, so I have to ensure. Hi Shania, good afternoon as well. Alright, so I'm not seeing any comments. I'm not sure if anybody is sending in the answer, and I'm not seeing it. But anyway, so today what we're going to do, we're going to do some flame test on some elements. Now each element is going to give us a specific or a special color depending on the element that we use. I think we'll be using various experiment elements rather. Kyra, could you just tell us what elements we'll be using today?
Well, the salts that we're using today are boric acid, barium nitrate, strontium chloride, potassium chloride, and sodium chloride, which is table salt. Oh, sorry. I'm sorry. So, again, hi, good afternoon, everyone. I'm Kyra Taylor, the president. Also, as you can see from the banner, ensure that you're registered for this meeting. The registration form is in the description box. Please ensure that you register so that we can keep track of who is attending the meetings. So we have boric acid, barium nitrate, strontium chloride. There's very little strontium here. Potassium chloride, and we have sodium chloride, which is table salt, and we're going to use methanol for alcohol because, as you know, we're just going to pour the salt into these containers, spray a little ethanol in the bowls and then set it on fire. Then we're going to have different colors for you guys to see. It's different in the light as it is in, and it's different in the light than it is in the dark. So we're going to try and show you how it looks in the dark so you guys can see the colors more vividly. So yeah, back to you, Ramin.
Alright, thank you, Kyra. Let me just move it there. Alright, so she explained it fully. No need for me to add anything more. So, oh, I've just seen the responses coming in now. So, Tashik says, yeah, put it simple. We're just setting some elements on fire. Okay. J. Wilson, the flames detect different elements present based on the color. Alright, I think we'll clear that up a bit more as we go along. Alright. Um Simone, chemistry, no voodoo here, no voodoo. It's just chemistry. Alright. People use chemistry to other means, but it's just chemistry here. Even when you think it's magic, it's just chemistry that the magicians are using. But no voodoo here. And Paul says, wow, I'm interested in boric acid. Alright. Okay. Does anybody have an element that they like? For example, sodium, magnesium. Here Paul is saying that he likes and he's interested in boric acid. Are you interested in seeing anyone in particular? Sodium, magnesium, any one of those? Okay, so Kyra, we'll sort out the request form issue. When I try to sign the form, it says the request edit access. Okay, so Kyra, just have a look at that. They're saying that the request form is requesting that they get request to edit. So I think you need to free something up on the form. So Kyra will have that dealt with very soon. Not an element. Alright, so And Tashik is also saying not an element, but I love acetone. Yeah, I think I like acetone too. Think I like acetone too. All right, so they're just getting ready for us to go. They're getting ready for us to go, so they're setting up. And we're going to try as best as possible to turn off the light. I think they went into a lecture theater, so we're going to try as best as possible to turn on the light, turn off the light, so that you can see the full effect of the light. Now, the basic chemical principle behind this. Give me one moment. Let me just set this up. All right, so good. So the basic chemical principle behind this is that we're going to dissolve the element, the salt of the elements. We're going to dissolve them. So we're going to use something flammable. And in this case, we're using ethanol. Now, the reason we're using something flammable, we want when we light the solution, it lights instantly. Or as we put the lighter in there, it just lights up. So that's the reason why we have to use something flammable, right? So we're going to dissolve the salt of the element in ethanol, and once it's dissolved, we're just going to set it ablaze. Now, when the solution is lit and it catches fire, what happens is that the atoms of the elements, they are receiving enough energy where the electrons can move up energy level. So they basically will jump to a higher energy level. Now, when this happens, it's absorbing the electrons, they are absorbing that energy. So the only way they can step up is when they absorb the energy. So once they absorb the energy, what happens is that they will fall back down to the energy level where they are coming from. Now, in falling down, they emit a certain wavelength of light. Now, for each element, the wavelength of light is going to be different because the electrons are essentially moving at different quantized energy. So that when they jump up, each element has a different energy to which it jumps up to, or it has a different wavelength of light at which it absorbs. So when it absorbs that energy, when it falls back down to the original level that it's coming from, or a lower energy level, it emits a particular wavelength of light. And depending on the wavelength, you get different light. So you get red, some of them you get green, for one you get lilac, for some you'll get brown. And I'm not telling you the elements because I want you to guess them further down, and we'll have something for the person that guessed them correctly. So I'm not telling you the elements, I'm just telling you the colors. I'm not telling you for which element you're going to see which color. You guys are going to guess that, alright? So, okay, Kyra, how are we doing now? Are you ready? Kyra?
Yes. Can you see me? Hello? Yes.
Yes, yes, we're
Hi.
seeing you.
Hi everyone. So we're gonna get started. So do you think I should go from this is my right? This is my left and right. From right to left or from left to right?
Anyone will do.
So guys, you want me to go from this end to that end or that end to this end? But I'd like to give you some control of what is going on here. All right, so we're gonna get started. I'm going to pour a little in here. Hit the lights. The as in that one. Yeah. Oh, shit. It's not. You can see.
All right, so you guys seeing the light? Kyra, can you do that again for us?
What you say, Romain?
Can you do that
If we
one
can go
for us
again?
again?
Yeah, sure.
Yeah. And close that the door at the side. Try to close it.
There's no door open, but okay. We'll try
Oh,
to. We're going to switch over cameras for a moment so we can see if we can get better quality.
all right, no problem.
Is it?
Right? Yeah, I'm back. I'm back. So yeah, that was just preview. As you see, we have a lot of them lined up for you. So question, I have a question, right? So you can just shoot the answer in the comments. All right, first of all, what was the color that you guys just saw? What color did you guys just see? All right, so Paul, in the meantime, I can answer this. So Paul is asking why we dissolve it in ethanol. All right, cool. So as I said before, we dissolve it in ethanol because, all right, so we could use it's a salt, so we could use water, but because we want to light the solution, right? It will dissolve to a good extent in ethanol. It's not like it's insoluble in ethanol or anything like that. And ethanol does have polar qualities, and the salt is polar, so it will dissolve not as readily as it would in water, but it will dissolve in the ethanol. And the reason why we do this is because we want to light the solution on fire. No, you can't light water on fire. It won't get lit. So that is why we use the ethanol, you know? Alright. So yes, Tashi said she saw green. Anybody else? What color did you see? Don't take Tashik's word for it. What color did you see? Okay, so recall the recall let's bringing up his mom. Alright, Paul. I like Paul, you're going good, man. Paul said that he saw a mixture of what? Blue and green. Alright. And Tiffany agrees. Tiffany says blue, green. Alright. Alright, we're going to do it again so you guys can see it clearly. Not saying anybody is wrong or right or anything. I just want to test you guys to ensure the scene and everything like that. Alright, so let me see what the guys are doing here.
Oh, I mean, don't take off Cairo.
Alright, so getting it ready for you guys. Alright, you guys see that? Loving the flames, Cara, loving the flames.
Well, thank you. Mhm. Oh. All right, so moving on. If you can tell me which one this is, just shoot
Yes,
a comment.
which element or compound do you think that was?
So remember, the compounds that we have here are potassium, potassium chloride. In no particular order. Yeah, in no particular order, we have potassium chloride, barium nitrate, strontium chloride, boric acid, and sodium chloride. So which one do you think this is?
Alright, I'm waiting on them to send in the comments. This thing has a delay, you know, so. But yeah, obviously Tiffany and Tashik, you guys are right. It's green. I I think I'm seeing a tint of blue as well. I'm not I'm not sure. I'd say I'm seeing that as well. I'm not sure. Alright, so Kyra Akila says copper. Paul is saying neon. Oh, you mean color. You thought different thing. Neon green. Oh, so ignore that. So Kyra, Akila is saying copper. Jamila is saying barium. Any others before I allow Kyra to tell us what it is? Any more? Alright, so Kyra, go ahead. Tell us what element that was.
Right. It's boric. Why is it not showing? Boric acid.
Alright, so that was boric acid. Alright, so that was boric acid. Alright, Kyra, do that one for us again. Reset and do it again, okay? Alright, so first of all, yeah, what color did you guys just see? What was the color? What was the color? Send it in the comments. I know it's hard to see, but at least try to give us a suggestion of what you thought the color was. Waiting in the comments, you're waiting in the comments.
Jamelia
I'm
and
going to.
Jamaica, right? So we're not even for us.
Alright, so Tiffany says that it started off what? Light blue. And then what happened? Alright, we're getting some consistency here. See Paul saying that it transitioned from light blue to yellow for you. Okay, and Tashik is saying blue. Alright, so Kyra, can you just go ahead and tell us what was the color of the flame, just to clarify for us?
Awesome. It's blue.
It was blue.
Blue. It started off blue and then it started getting into the orangey. Okay. But
Alright.
Akeelia and Jamelia are right. They are right. It is barium nitrate and well, barium if we're talking about Jamelia. But yeah, it is barium nitrate. As you can see, can you do the YouTube please? So let me look on YouTube, right? Barium nitrate, yes. So we're gonna go down the line. Let's go. Next. Are you ready for this, guys? Are you ready for number three?
I think they're ready. Go ahead. All right. So I know you guys saw that one. I know you guys saw that one. Oh, okay. So, okay, Kara. So, I'm not sure what you guys need to fix up, but they're saying that they're not hearing you guys clearly. All right. So, but yeah, in the meantime, what color did you guys just see? That one was obvious. All right. Paul said red, orange. All right. Anybody else? Anybody else? What color did you guys just see? Send it in the comments. Send it in the comments. And I think there's a delay, so I always have to be killing the time. Anybody else? What color did you guys just see? It's obvious. I just want you guys to say it. All right, not seeing any more coming in, but yes, it was red. Obviously, it was red. It started off a bit, what you'd say, the orange. It started off orange and then it gradually turned to red. And I see Akila saying that yes, it was red. We have the delay on this side, so I kind of see your comments late, okay? But yes, and for some clarification, I think the orange color is not the element. I don't think it's the element starting to burn as it, because alright, if you guys just have a lighter and you light it, you always see the blue at the bottom, and then you see at the top you see the orange color. And I'm sure all of us are used to that orange flame. So I don't think the orange color is the element. I think as you go along and as you see the red color starts to fade in, I think that is when the element itself started to burn and release that wavelength of light, and then you started to see the red. But anyway, Kyra, could you just tell the guys what that element was, the one that gave us the red color, before you move on? Yeah.
Properly.
That's the same one, right?
Yeah, strontium chloride.
All right.
Yeah, so, yeah. So the
Yeah, so that was strontium chloride, and the strontium is the one that is giving us the red coloration. All right, moving on to the next element, Kyra. Over to you.
All right, so we got this.
Oh, this one looks good. When the fire is out, just light it again, alright? And you guys, tell me what color are you guys seeing? Tell me the color. Send it in the comments. Tell me the color that you guys are seeing.
Right? Mm-hmm. So this is
Alright, reset it for us, Kyra. Ooh, pay attention, guys. What color are you guys seeing? Try to figure it out. Just send it in the comments. Can you do it one more time, Kyra? Or is it all burnt out? Alright. What color are you guys seeing? Alright. So I'm not sure if you guys are commenting. I'm not seeing anything coming up in the comment section. Let me just give it some more time. All right, Kyra, go ahead and tell us what color was that.
The color is supposed to be lilac, but it's hard to see. If we were, you can, yeah, all right now. If you look, if I wish we could just show you guys, but it's dangerous for us to like point fire towards ourselves. But it's lilac, so it's a light, very, very, very light purple, purplish color.
Oh, okay. So yeah, all right. So that one, I don't think we could have expect you guys to get it. Seeing that we're using the phone camera to stream this. So she said it was lilac, which is basically a very pale purple. All right. So through the lens of the phone, you probably might just see white light or yeah. As I said that if all right. So Paul is saying that he's seeing orange. So
That's an
which
element.
yeah, which was I was saying this before that if you're seeing orange, I don't think the element started to burn as yet. If you get what I mean, I think it's other things, probably the ear, because if you just light a lighter, you're going to see orange. And also probably it's the ear that is burning, and as the fire starts to burn through the solution and it starts to burn the element, then you see the color. But as Kyra said, it was lilac, so you wouldn't be able to see it as clearly as possible. Tiffy said that it started blue and turned yellow. The phone camera trick you. Phone camera trick you. But okay, Kara, let's move on to the other element.
I know the element is burning. She probably said that, yeah. And now the element is burning, so that's what he's saying. Oh gosh.
Keep it lit, keep it lit.
No, Romain, we can't remember. It's just remember another show Zohan is right. We're not trying to burn anybody that can't go to prison. I'm too young.
Okay, so could you reset that for us? Or can you? And Kyra, try to put a bit more of the salt in the crucible, okay?
Mm-hmm. Yeah.
Alright, so our advisor, I would call him our club advisor, Ricardo. He's giving us a proper explanation for the orange color, and he's saying that there's a small amount of salt in the crucible and a large amount of methanol. So the methanol is burning and giving off an orange color, and that makes total sense, okay? So I think, yeah, so the methanol is burning before the element, or it's burning significantly before the element starts to burn. So at first we're going to see the orange color, which is the methanol burning. And then as the methanol starts to burn off, and recall you can back me up here if I'm correct, as the methanol starts to burn off and the salt itself starts to burn, then you will see the characteristic color of that salt being emitted. But the orange color you're going to see it first because the methanol is going to burn first. I do have a question though. Alright, so this one is probably for the students who do chemistry, right? So we're doing this experiment, and as you guys can see, because we're using the phone camera, it's a bit difficult to see the color that is actually there because of the phone camera. And what the phone is doing is, because the light is bright, so it's trying to dim down the brightness. So I think it will do something automatically and dim the light and all sort of stuff. So which is why you might have some difficulty in seeing the actual color. Now we are scientists, and when we face issues like this, of course we will want to try to solve them, and we'll want to make the experiment a bit better for the next time when we will do this, or seeing that we're streaming this experiment live. So what is one suggestion that you guys would suggest to us, or just in general, what would you suggest that we do to ensure that we see the characteristic color of the element a bit brighter? And yes, here Ricardo is saying that it's correct, so good. So anybody, any suggestion, and I promise if somebody gives me a good suggestion, I have something for you personally. I'll promise you something. So you guys can just send it in the comment. What suggestion would you give? Seeing that because of the phone camera, we're not able to see the light, the color that the element is giving off as brightly as we would want to, seeing that the phone is auto-correcting and it is basically preventing us from seeing the color clearly. What suggestion would you give to would you give? And I promise Ricardo is here, so he and myself will judge the answers, and the best answer, we have something for you. The person that gives us the best answer, we have something nice here for you. So send it in the comments. I'm not sure if you guys are sending anything because of the delay, but please just give it a try. You never know what could happen. So again, I'll repeat the answer. So I'll repeat this scenario. So as it stands now, we're having difficulty seeing the color of the element, or the color that the element is giving off, due to the fact that we're streaming live and we're using cameras, and the cameras is auto-correcting because the light is too bright. So it's doing what it's supposed to do when it's auto-correcting, but it's not working to our favor now because it's preventing us from seeing the color as clearly as we would like to. So what suggestion would you give to help to, if not solve, lessen the effect which it is having? And in the meantime, while you guys are sending in your suggestions, I'm just checking in on Kyra. What are you guys doing? Are you guys setting up the other ones?
We have some random ones, we don't know what's in them. Them.
All right, so I'm waiting on somebody to send in a suggestion before we progress any further. Want to see if you guys, if we're using up our analytical problem solving minds. So I'm waiting and waiting. Nobody sending in a suggestion? We have no young chemists or upcoming chemists in on the stream. Send in a suggestion. What do you guys think? Alright, so we have our first suggestion. So how about take a picture of the reaction with a high quality in front of the color spectrum and post it on Instagram? Alright, that is actually a good suggestion, not bad. But let me make a clarification though. Which is why I said that this one might be for somebody who does chemistry. But I like your suggestion, Javon. I'm not sure if you do chemistry, but I like your suggestion. But the solution to the problem, I want it to be that we're making a change to the way how we do the experiment. So I'm not talking about the camera or anything like that. Like we can't do anything to the camera. We can take pictures of the experiment and post on Instagram. And as I said before, that is a good suggestion, a quite good suggestion. But what could we do to the experiment, as in our method? What could we do to the experiment itself to help solve the problem of not being able to see the color clearly? So as I said, good suggestion, Mr. Anderson, but I'm clarifying. What could we do to the experiment itself to ensure that we can see the color a bit more bright? You guys send in your suggestions. No, well, I won't say that there's no wrong answer, but I think you should try. Once you try, and even if you get it wrong, once you get your clarification, you'll never forget this. You will never, whether or not you're a chemist or not, you will never forget it. Simone, our secretary, is saying that remember to click the link in the description to register. And I'm assuming that the issue that was there before, it has been sorted out. So when you guys get the time to just click the link in our description to register. Alright? Anybody sending in a suggestion? Nobody. I'm waiting. I am praying that it's because of the delay. I am praying that it's because of the delay. I am not seeing anyone sending a suggestion as yet. But I'll give you guys some more time. Anybody, you can try anything. Anything that if you just have an idea, anything that you think we could do to the experiment, to our method, probably the amount of whatever we're using, probably we can alter that. Anything. But in the meantime, while you guys are typing your lovely suggestions, we'll go back over to Kyra. So go ahead, Kyra, with the rest. I see Kasha there. Hi, Kasha. Kyra, unmute your mic.
Hi everyone. We're just lighting some random ones. We don't know what's in them, the cells that are in them, but I guess you can guess what's in them based on what we've shown you before. Why is it so hard to?
Alright, reset that one for us. Alright, cool, cool, cool. That looks good. That looks good. So obviously, we're seeing the blue coloration, and then we're seeing the orange. Now, it's very important to note. You see, when you see the experiment, you're supposed to be able to, a good extent, explain what is happening. So okay, so she poured the methanol. Oh, it's not ethanol we're using, it's methanol. So she poured the methanol in the crucible, and then she lit it. And then as she lit it, immediately we saw the blue coloration. And as it progressed, we started to see the orange color. Now we're chemists and we're problem solvers, right? And we're supposed to at least be able to explain what occurred as the experiment progressed. So I would say that immediately as she lit the solution with the crucible, the element started to burn, which is why we started to see the blue color right away. Alright, so I guess it's sufficiently dissolved and probably it's on the top, and as she lit the solution, we started to see the blue coloration, and that is telling us that the element started to burn. And as the experiment progressed, we started to see the orange color, which is telling us that the methanol is starting to burn. Or the methanol, what should I say? Because both of them are burning, and it's just that we're seeing the orange color more than the blue color at that point in time. So we can say that the methanol is being burnt more than the element, or probably the element it has burnt right out, and we're starting to see the orange color. So I just wanted to highlight that looking at the experiment, you're supposed to be able to explain and elaborate what is happening as the fire is burning. So Kyra, you can go ahead with the second one. Alright, so I'm seeing the blue, and I'm not sure if anybody is seeing the red. I'm seeing the red. Do it again, Kyra. Alright. So I know you guys seen the blue. Am I the only one that saw the red, Kyra? Can you just clarify where was there
Yeah,
red?
there is red in there.
Alright. So we saw blue,
You're hearing me clearly, right?
and we saw red. Is Ricardo in there?
No,
Okay,
sir.
okay. I thought I heard his voice. Alright, so we saw blue and we saw red. I'm not sure if you guys are commenting, but did you guys see the blue and the red? Just shoot me a comment. Alright, I see Javon Anderson is saying that he saw the blue and the red.
Can you see how many people are there?
Alright, good. So at least, alright, good. So you guys are seeing it. Alright, so Simone, just take a look at the comments, okay? Alright, so again, let's go with the explanation. I like doing the explanation, you know. I like doing the explanations. So boom. So when the fire just when Kyra lit the solution, at first we saw blue, then we saw red, and then we saw orange. Based on the explanation I did before, I think can somebody please, I am somebody try to do the explanation. Explain why we saw blue, then red, and then orange. I I have something for you guys, you know, man. Nobody wants it. Come on, give it a try. Give it a try. We have Jevon. Jevon did his suggestion, and Jevon is in it already. I don't know who wants to compete with Jevon for the top place, but can anybody just try to give a suggestion to why we saw blue first, then red, and then orange? And I'm waiting 30 seconds to ensure that it's not because I'm of the delay where I'm not seeing the comments. All right. So, all right, I'll go ahead, and hopefully what I say is with accordance with what you think. All right. So somebody sent in a suggestion. And Simone is saying, just an announcement. Send your names in the chat, guys. I'm not sure what is happening with the registration form, but remember that we have to keep track of your attendance, so that if you want to join the club, remember you have to attend 3 meetings, whether or not it's online or in person. Everything is online now, so we have to keep track of those who are coming to our meetings, so that we can take a register, so that when you pay your membership fee, we can say, all right, this person came to more than to 3 meetings or more, so we can just sign you off as being a member of the club. All right, so we have a suggestion here, and before I put it up, thank you for sending in your suggestion. I'm glad that you're participating. All right, so Javon is saying the hottest section of the flame is blue and the coolest is orange. All right, this is actually interesting because it is true to a certain extent that that the blue section of the flame is hotter than the orange. All right, and let me just add a bit of clarification to this. All right, I wish I had a lighter, but when you guys light a lighter, right? Kyra, can you is that a flint? Is it a lighter or a flint in your hand? Oh, it's a flint. Okay, okay. All right. So when you light a lighter, right? You notice that we always see the okay, good, good, good. All right. So you guys can clearly see the orange part at the top, and you can see the blue side, the blue part closer to the edge of the lighter. All right. All right, good. Thank you, Kyra. Now, what Javan said, the blue part being hotter than the orange part is correct. You see right at the border where you have, so this would be the orange light and this would be the blue light. Right at the border at where they join, I would say right about there, that area would be the hottest part of the flame. Like if you took a thermometer and place it there, right at the top part of the blue, right before you reach the orange part of the flame. As I said, would be the orange part and this would be the blue part of the flame. Right at the top of the blue part of the flame, right before it reaches the orange part, and even some parts of the orange part of the flame, I would say that is the hottest point in the flame. If you go too close to the entrance of the lighter, it won't be as hot because not all the gas or whatever is being lit, whatever flammable reagent is being lit, not all of it would be lit right there and then. So by the time it reaches up to where you have the orange point of the flame and the blue point of the flame, I would say that is the hottest area in the flame. So you are correct in with regards to that. But in this experiment, remember that we have salts that are giving us colors, right? So the explanation that would be correct in this case for this experiment would be that we saw blue first because the element that gives us the blue flame, that was the element that was being burnt in excess. After which we saw red, which tells us that either the element which is giving the blue flame, either that element is being burnt out, or the element that is giving us the red flame, that element is being burnt more than the element that is giving us the blue flame. All right, and then we are seeing the orange color after because it's the methanol that is being burnt. All right, so that is the explanation for what is happening. I really wish you guys would give your suggestions to why you think it's happening. Jevon, you're in the runnings for the top spot, and I'll speak to you after if no one is contesting you. So Kyra, go ahead with the other one. Unmute your mic.
I mean, I'm not doing anything. Even body, I don't want to burn. Wait, even. Again, guys, we don't know what's in the
Is
crucible.
this the last one?
No,
Alright.
there are two more.
Just light up everything now.
I mean, I only have one hand.
Alright, so she's going to just light each crucible now. And let's get it over with. Because I think these crucibles had salts in them from before. And we don't want to waste them. Any chance that we get to light fire, we're going to light fire. Alright? So that is why we just run into them. All of them blue though. Oh, this one is wow.
Hold on. Shit.
This one is nice.
Yeah, that one is very nice.
Alright, see it there. See it on the shot. Lord. So guys, I'm
Yeah,
gonna do
that
that
one
one more
was
time.
very pretty.
I'm gonna fix this up. I'm gonna do it one more time. We're just gonna bring things close, move things away from the outlets and the gas line. Yeah, I'm gonna do that. Yeah, yeah. This is how we have people around. I forgot all about you. I'm so sorry. Well, just don't turn into a big fire, you know. I don't have what. Well, I have water on me. I don't think I'll
And
be able
try
to
to
get
turn off the light for this one, because this is the big finale. We
I
just
mean,
lighting them.
lights are off now.
The lights are off, but the blinds.
The blinds we can't.
Okay. Alright.
Just please. Mid strength.
Wow, you see that green, guys? Give me a good view of the other ones too.
Listen, well, we can.
I really like that green. And it's not because of any political affiliation. I just like how that green looks. I like the red too. Alright guys,
Listen,
at least send your flames in the comments. Send the orange flame
listen.
emoji. I think it's only orange in there. We're just lighting fire for you guys. You see how beautiful it looks? Be careful guys. Alright, and just for clarification,
I mean,
go
can you hear
again?
me?
I'm
So,
hearing you.
guys, since we're trying to keep the flames to a minimum, I'm just going to light these three right here. And then I'm going to light these two over these three right here. So we can keep the flames to a minimum. It's a lot of fire in one time, at one
Okay,
time.
anything to
So we're going to do the green that you love so much again for the people for the finale. Right? Yes, please. Oops. Mhm.
That's the green, lilac, and blue, right?
Somewhere it's supposed to be.
Yeah, and so guys, the green color is from the copper sulfate.
No, babe. It's the boric acid.
Oh, it's boric.
Yeah.
All right, list them out because I don't know the compounds that you guys have there. All of them.
So we have boric acid, barium nitrate, potassium chloride, strontium chloride, and sodium chloride, which is table salt. It's just salt from my kitchen. We didn't have because sodium chloride.
You
You
can
can get it
say
from
like the colors of each.
the colors. All of them are white. All the salts are white. And then so that's why we use the flame test to distinguish between each salt. Because if I say, all right, so look at this. Can they see? We hit the lights. If you look at this, right, you're not gonna know what this is. If you look at this in comparison to this, aren't they basically the same thing? Well, this is not content. Anyway, they're basically the same thing. If you look at this and this, they're basically the same thing. So you use the flame test to distinguish between the different salts. So each ion in the salt exhibits a different flame. So as you know, the barium nitrate, this was barium nitrate, the Ba2 plus, gives off a distinct blue flame. The sodium, the Na plus ion is supposed to give off a distinct yellow flame.
Yeah.
So we are sorry that it couldn't show so beautiful today. The strontium, which is Sr2 plus, it gives off our red
Red.
flame. Potassium K plus gives off a lilac flame. Yes, I want to remember what is this? The ion. Flame.
You're mute.
Boron ion, the boron ion gives off a distinct green flame. So that's what we're just trying to show you guys that a lot of these salts are similar in color, and the flame test is just there to distinguish between them, and also them look really cool. Like, who doesn't like seeing things being set on fire? And that's just continuing our trend from last week. If you haven't seen the smoke bomb experiment, please check it out. The video is on our channel. And we're going to post some pictures of the flames for you guys on our Instagram. But this is really the last of it. I'm just gonna not the end of it. Yeah, so many. See guys, so in the light, this is why it's so important to turn off the light. Yeah, man. So thank you guys for being here. Thank you for bearing with us for the entire like hour and a half, I think. Um, Next week we're going to move on to a different medium because we want it to be more interactive. If you haven't started the crystals experiment, making your own crystals experiment, I am asking you to start. It doesn't matter how far you reach, as long as you at least try. Because as chemists, as persons that are interested in experiments, you should be able to follow simple instructions and just carry out a our CEO, which is our Chief Experimental Officer, Kasha, just suggested that you don't have to go beyond the first section in the instruction. That's just part one. You don't have to go past that. You can just stop there, send the pictures, send your videos. You don't have to participate, like you don't have to do the recrystallization. So Kasha is saying that the recrystallization is for persons that have strong hearts. If you don't want to recrystallize, you don't have to do that. You can just make your crystals, take your pictures, take your videos, and send it to our email because we want to, give you guys a chance to do something. You're not here in the room with us. You can't handle the lighter, you cannot pour in salt, and you can't spray the methanol. So we want you guys to have something to do while you're at home. Um, please remember to sign the registration form in the description box. I don't know
I think
what is
something is wrong with it, so they send in their names.
if
Simone
you're
taking
having
the names.
an issue. Yeah, so if you're having an issue doing registering using the form that's sending in the chat, Simone will write it down. But yeah, thank you guys for coming. I hope you're here next week. I hope you're, having a wonderful week. I hope you're having a wonderful first month of the semester, because I know that you were rough and that chemistry, if you're doing chemistry, if you're doing anything in this faculty, it's rough right now. And with COVID-19 and the online learning, it's kind of hard because you have slow flow and you have digital and you have JPS trying to mash up your life. But, guys, keep positive, study, buckle down, ensure that everything that you need to succeed is already in place, and just keep pushing forward because, at the end of the day, it's your degree. At the end of the day, it's your life, and you want to make sure that you are, achieving something that you're, making the best of a bad situation because COVID is a bad situation. Nobody woke up one day and thought that 2020 would be in so much shambles right now. And all you have to do now is push through. So I'm going to just like this one more time and then we can just, hand it over to Remy. Okay, stop.
All right, Kara. Well said. Well said. While she lights up,
Remy, with the chemist and you love the reaction. Ooh.
yeah. Experiment with the chemist, and you'll
And
love the
you
reaction.
love the reaction.
So we just burn up things. We'll just like do them thing, those things here.
All right. So in the meantime, guys, you guys can just send in your names in the chat so that our secretary sees it and makes a record of it. And yeah, Kyra said everything that possibly could be said. The only thing is that next week or the next time we're going to try to see if we can make it a bit more interactive, meaning we'll be moving probably to Zoom. Alright, so look out for that for next week. Thank you guys for joining us. It has been, you guys have been here consistently. I haven't seen it below 14, so thank you very much, guys, for being here, being loyal to the club. It's very difficult to do chemistry, stream chemistry, but we're doing our best, and I hope you guys appreciate it. So, we'll see you guys. Peace. I'm gonna leave this here so you guys can send in your names. I think that is everybody though, but I'll just leave it up for about 4 minutes so you guys can just send in your names in the chat. Alright, let me see if I can at least add something here. Alright, that was it. I was just giving you guys a sample of that. Alright, so we'll see you guys. I'm going to end the broadcast now. I still see names coming in. Hurry up, guys, and send in your names. Alright, guys, we're out. Peace.